Shh. I just borrowed it from the library, thank you. Shh. A complex fraction is a fraction that has more fractions in it. So for instance, do you notice this one? It's a big fraction, but in that big fraction there are many other fractions in the numerator and the denominator. That is called a complex fraction. A fraction that has either in the numerator, the denominator, or both, it has more fractions. And the way that we do these, you have to consider the numerator as a separate problem and the denominator as a separate problem, and do those first. And then when we're all done, we'll consider the big fraction. But first, the numerator. How do you do 7/12 minus 1/6? Right. You have to get a common denominator. And for that one, what will the common denominator be? For that one, what will the common denominator be?
12.
It will be 12. So, the first one already has a 12. I leave that alone. So, 7/12 take away. If you have to, go off to the side. 1/6 is how many 12s? What did I multiply by?
2.
So I'm top by 2, and I get 2 12s. 1/6 is 2 12s. That 1/6 is 2 12s. Now actually work that out. What is 7/12 take away 2 12s? Right. So my numerator, I just get one term, it's 5 12s. You have to get it together into one thing. The same goes for the denominator, except what do I assume is underneath here?
1.
A 1, right. So again, I need to get a common denominator. What's the common denominator going to be? So 2 wholes is how many 9s? What did I multiply by? So on top, and that gives me 18 9s. So this one is 18 9s and 4 9s, which is, do you notice? I have one thing in the numerator, one thing in the denominator. At this point, you know the big fraction line that separates the two, this one?
Yep.
What does a fraction line mean?
Divide.
Right. So actually this means to take 5 12s and divide it by 22 9s. Well, you know how to divide fractions. What do? You leave the first thing alone and you multiply by the reciprocal, flip it, of the second. Top times top, bottom times bottom. You can cancel first if you want. 3 goes in here, 3 goes in here, 5 times 3, 4 times 22, and I think that's it. No, and it's actually stuff you've done before. You know how to combine fractions, get a common denominator. You have to do that twice. Once you do that twice, you know that this fraction line means divided by. You just do the top, divide by the bottom, and that's it. But of course, no, that's not it, because next we're going to do it with letters. Do you have any questions on that one? See that? Same thing. We've done it already. So you've got to get this together as one. You've got to get this together. And again, if you're subtracting fractions, you have to have a common denominator. What do you assume is under here? 1. Right. So what's the common denominator there going to be?
Z.
So this z over 1, I need to get it to have a z in the denominator. What did I multiply by? So here, so z squared over z. This first thing, take away, and put it all together over your common denominator, which is a z, right? Isn't that going to be z squared take away 1? Yes. Now I have to do the same thing in the denominator. I assume this is over 1. It's just 1 over 1. What's your common denominator going to be here? This one already has this, 1 over 1. I multiply, right? You probably don't have to do this. So it's z over z. So z over z, take away 1 over z. Z minus 1? So I got numerator all together as 1. I got denominator all together as 1. What does this line mean?
Divide.
So would you agree z squared, here's the top, divided by the bottom. How do you divide fractions? So you leave the first thing alone and you multiply by the reciprocal of the second. How would I do that?
You got a factor.
Right, you've got a factor. Remember when I said, like, when we first started factoring, it's going to keep coming back? And here it is again. This factors, z plus 1, z minus 1. Someone over here is annoying me. It's not you. So we can cancel. Here's a top and a bottom. Here's a z minus 1 and a z minus 1. What's left? Right? There we go. It's z plus 1. Isn't it easy? Pretty much. And again, well, it's just a little bit more involved when it has letters, but it's the same thing. Common denominator, put it together. Common denominator, put it together. Then it's a divide. We divide it, just multiplying by the reciprocal. And that's it, pretty much. Do you have questions? Well, I have one little thing to show you. No, I have one more little thing to show you. There's an example that looks like this. And I already know that you know this. You know that x to the negative 1 is 1 over x, right? You know that a to the negative 2 is 1 over a squared. You already know that. But I am? Oh, thank you. Who said that? Oh, is that you? Oh, how nice. I didn't know you thought I was so cute. So you're the one leaving me chocolate on my desk. Oh, how nice. You're such a good boy. He is getting right. Good. So we're talking about complex fractions. Wait a minute. You see this? It's got a fraction in the numerator, a fraction in the denominator. That's the definition of a complex fraction. Look at this. There's no other fractions there. It will turn into a fraction. And the key to doing this, you better listen up, because if anybody asks me this question, I'm going to get angry. The key to doing this is to think about this thing separate from this thing. They are two completely. Forget about it. And the other key is to remember this. Do you see this z right here? We did it over 1. Do you see this 2 right here? We did it over 1. So guess what we're going to do with these? They are over 1, over 1, over 1, over 1. Whoops, not over x, over 1. Because when you write it, you forget about this. How do I write a to the negative 1? It's 1 over a. How do I write x to the negative 1? And it sort of stays in the big numerator. Same thing with these. How do I write a to the negative 2? I bring it down. How do I do x to the negative 2? And that's just what you do if you want to solve it right. That's what you have to do. Does that make sense? You have to forget that there's a denominator and just make it 1 over, 1 over. You have to forget there's a numerator and make it 1 over and 1 over. And then you can get that common denominator ax, common denominator a squared x squared. You can finish it from there. Yes? Questions? Are there any questions? Does anyone have a question? We're good.